Mastering emergency shutdown systems. Ignoring hidden hazards in emergency shutdown systems is a ticking time bomb. Which steps should be taken to identify and prioritize potential hazards in an emergency shutdown system, and what criteria should be used to ensure that the most critical risks are addressed in order to achieve operational excellence? To identify and prioritize potential hazards in an emergency shutdown system, ESS, and achieve operational excellence, the following steps should be taken. 1. Conduct a thorough hazard identification and risk assessment, HIRA. This involves identifying potential hazards, evaluating their likelihood and impact, and prioritizing them based on their risk level. The HIRA should consider factors such as the type of process, equipment, and materials used, as well as potential human error. 2. Gather and analyze data. Collect and analyze data on past incidents, near misses, and equipment failures to identify potential hazards and trends. This data should be gathered from various sources, including incident reports, maintenance records, and operator feedback. 3. Involve stakeholders and subject matter experts. Engage with stakeholders, including operators, maintenance personnel, and engineers, to gather insights and expertise on potential hazards and risks. 4. Use standardized methodologies and tools. Utilize standardized methodologies and tools, such as hazard and operability, HAZOP, studies, failure mode and effects analysis, FMEA, or event tree analysis, ETA, to identify and evaluate potential hazards. 5. Evaluate the effectiveness of existing safeguards. Assess the effectiveness of existing safeguards, such as safety instrumented systems, SIS, alarms, and interlocks, to identify potential vulnerabilities and areas for improvement. 6. Prioritize hazards based on risk criteria. Use a risk matrix or similar tool to prioritize hazards based on their likelihood and impact. This will help focus efforts on the most critical risks that require immediate attention. 7. Develop and implement risk reduction strategies. Develop and implement strategies to mitigate or eliminate identified hazards, such as modifying procedures, improving training, or upgrading equipment. 8. Continuously monitor and review the ESS. Regularly review and update the HIRA to ensure that new hazards are identified and addressed, and that existing safeguards remain effective. Criteria for ensuring that the most critical risks are addressed include: 1. Risk reduction. Focus on reducing the likelihood and impact of high-risk hazards to minimize the potential consequences. 2. Compliance with regulations and standards. Ensure that the ESS meets relevant regulations, standards, and industry best practices. 3. Operational reliability. Ensure that the ESS is reliable and functions as intended in emergency situations. 4. Human factors. Consider human factors, such as operator error and training, in the design and implementation of the ESS. 5. System integration. Ensure that the ESS is properly integrated with other systems and equipment to prevent unintended interactions. 6. Maintenance and testing. Regularly test and maintain the ESS to ensure it remains functional and effective. 7. Continuous improvement. Encourage a culture of continuous improvement, where lessons learned from incidents and near misses are used to improve the ESS. By following these steps and criteria, organizations can ensure that their ESS is designed and implemented to minimize the risk of accidents and ensure operational excellence.